All right, today we're going to dive into a really fascinating piece of tech, something that could be a total game changer for fish keepers everywhere. A smart, solar-powered system that automatically takes care of the water quality in a fish tank.
So, have you ever worried about your pet fish when you're not around? I mean, if you've ever had fish, you know that feeling, right? That little nod of anxiety when you go on vacation, or even just head to work for the day, wondering if everything's okay in that little aquatic world you're in charge of? Well, that's exactly the problem this whole invention is trying to solve.
Okay, so let's start by really digging into the core challenge here, what we're calling the fish keeper's dilemma.
You know, keeping an aquarium healthy isn't as simple as just, adding some water and sprinkling in some food. It's this constant, tricky chemical balancing act. You're manually testing for pH levels, adding a few drops of this or that. It takes consistent effort and, frankly, a good bit of knowledge. And the stakes here? They're incredibly high. We're talking about a sudden spike or a big drop in pH that can be absolutely disastrous for your fish. As the source material points out, these imbalances can lead straight to stress or even worse, turning a hobby you love into something really frustrating.
But what if technology could step in and take all that guesswork, all that constant manual labor, right out of the equation? Well, that's exactly the promise of the solution we're looking at today, an automated guardian.
Just think about it. What if you had a personal chemist watching your tank 24/7? Someone whose only job is to make sure your fish tank's water is absolutely perfect. That's really the core idea here, a dedicated, automated guardian for your aquatic pets.
So the official term for this is aquaculture automation. And what that means is this system doesn't just ping you when there's a problem. No, it actively monitors the water's pH and, this is the key part, it automatically dispenses the right solution to get everything back in balance.
All right, so how does this thing actually work? Let's get into the nitty-gritty and see what makes this smart system tick.
Okay, check this out. What's so cool here is how simple and elegant the hardware is. You've got an Arduino board at its heart. That's the brain of the whole operation. It gets info from a pH sensor that's in the water, and when it decides it's time to act, it tells a little servo motor to release the stabilizing solution. Super straightforward.
And you can actually break down its whole process into 3 super simple steps. First, it senses the pH in the water. Second, that Arduino brain decides if things are out of whack. And third, it acts, using that servo motor to add the fix. Sense, decide, act. Simple as that.
And if you really want to see the system's thought process, this flowchart lays it all out. You can follow every single decision it makes, from checking its own battery to evaluating the pH, and see exactly how it decides whether to do something or just wait.
But really, if you boil it all down, the single most important question it's asking itself over and over is this: is the pH in what the creators call the danger zone? And this table shows us exactly what danger means. See, if the pH dips below 5.1 or shoots up past 9.0, that's when the system jumps into action. The whole goal is to gently nudge the water chemistry back into that perfect optimum range between 7.0 and 8.0. So, now let's talk about what makes this system truly special. Because it's not just what it does, but how it does it that's so incredibly innovative.
And this brings us to a really crucial distinction. See, most smart aquarium systems out there, they're passive. They just watch the water and, send an alert to your phone if something's wrong. But this system, it's active. It doesn't just tell you there's a problem. It finds it and it fixes it all by itself. This whole ability to self-correct, that's what engineers call an integrated feedback loop. It's this constant cycle of sensing, deciding, and acting that just happens in real time with zero human help needed. And for hobbyist-level gear, that is a massive leap forward.
And here is the other absolute game changer. That W stands for watts, and the whole system can run off a teeny tiny 5-watt solar panel.
So what does that mean? Well, it means the system is completely energy independent. It can run 24/7, even if you're in a remote or off-grid spot. Plus, it seriously cuts down the carbon footprint from running all that aquarium gear. It's a green solution in pretty much every sense of the word.
Okay, this all sounds amazing in theory, right? But the real question is, how did this clever little device actually perform when put to a real-world test?
Well, the creators did just that. They put it to the test and had a user survey its performance. This chart here shows us the results. The green bars are where it's exceeded, and the red one, well, that's a problem area.
And the results are pretty clear.
It was a huge success in its core jobs. The automation, the accuracy of its monitoring, the effectiveness of its actions, they all got top marks. This really proves that the basic concept is solid and it works just like it's supposed to.
But you know what's also really telling? That one low score. Pond pH stability was rated as a problem. And honestly, that's great to see. It shows that while the system reacts really well, keeping a perfectly stable pH is still a huge challenge. And that points to a clear path for making it even better in the future.
And all of this brings us to the final piece of the puzzle. How do you get from this awesome prototype to an actual product that you and I could buy in a store? Okay, let's talk about the cost. The total price to build this thing was just under 342 Malaysian ringgit. I mean, that is incredibly affordable. It makes this kind of advanced tech accessible not just to big commercial farms, but to everyday hobbyists too.
And that low price point? It opens up massive commercial potential. The target markets are obvious. People with home aquariums, small-scale fish breeders, you could totally market this as an affordable smart tank solution. Plus, since it's modular, you could easily add upgrades later, like a phone app or even an automatic feeder.
So, that kind of leaves us with a final thought to chew on. As technology like this gets cheaper and more sustainable, it's really not that hard to imagine a future where every single fish tank has its own little solar-powered guardian watching over it. The only question is, how soon will that future get here?